Hi students, in this video we are going to see about 8th standard physics chapter 4 energy. We are going to learn the following topics. The learning objectives are introduction about potential energy, types of potential energy, gravitational potential energy, elastic potential energy, and finally we are going to see some numerical problems. Students, first we are going to discuss about what is potential energy. The energy possessed by an object due to its position is called potential energy. So students, last video we discussed about kinetic energy. What is kinetic energy? All moving object has kinetic energy. So potential energy means what? Potential energy means if an object at rest, the rest object has some energy, the energy is called potential energy. So students, you can see this picture. These are all some examples of potential energy. So next we are going to discuss about types of potential energy. So already we discussed about mechanical energy. The mechanical energy has two factors. One is the kinetic energy, another one is the potential energy. The kinetic energy already we discussed. In this class we are going to concentrate on potential energy. Potential energy again divided into two types. Again it is divided into two types. One is the gravitational potential energy and another one is the elastic potential energy. So in this video we are going to elaborately discuss about these two types of potential energy. So students, first we are going to discuss about gravitational potential energy. So already we know that about work done. So when we discuss about work done, we discussed about work done against gravitational. So what is work done against gravitational? When an object is lifted against gravitational force is called work done against gravitational force. So like that, the energy acquired by a body when it is raised at some height from the ground level is known as gravitational potential energy. You can see that the picture. So any objects when it is lifted from the surface to some heights, it's against to gravitational force. So this is the gravitational potential energy. So this energy is stored in the body due to the work done on it. So when it is raised against the gravitational force, so if we want to lift any object from the surface, we have to give some kind of force to lift that object. The force, that the energy is stored in that body when it is raised against to gravitational force. So students, the gravitational potential energy depends on two factors. One is the mass of the body, another one is the height. Okay. So gravitational potential energy is depends upon mainly these two factors when it is lifted against to a gravitational force. So students, greater the mass or height of an object, more the potential energy. So simply you can understand, if the object weight is very higher means the gravitational potential energy is also very high. So sometimes when an object is placed in a very height, so that time also the object has very high potential energy. So students, next we should know the formula for gravitational potential energy. The formula for gravitational potential is also is same when we studied about work done against gravitational force. So both formulas are the same. You can see here the gravitational potential energy is equal to mass into gravity into height, mgh. So where m is the mass of the body and g is the acceleration due to gravity and h is the height of the body. So student, next the ground is considered to be position of zero height. You can see this picture. So when the person climbing started to climbing to the mountain, the beginning point is the zero height. They started from this zero height. So when they are started to climbing into the hill, so they are started to gain energy. So when they are reach out the top of the mountain, they the object has potential energy. So, students, the gravitational potential energy of an object is directly proportional to the height of the above the ground. Okay, directly proportional to the height above the ground. Already we know that if the height is higher, the potential energy is also higher. When the mass of the object is higher, the potential energy is also higher. Okay, students. If the height is double, then the gravitational potential energy is also doubled. So, from this example, we can easily understood. So students, next we are going to see some examples. So already we know that if the object is in the height, the object has potential energy. So you can see these examples. A rock situated on a hill. Okay, rock is placed on the top of the hill. Is it in the rest position? The rock has potential energy. You can see that the second picture, a ball kept on the rooftop. You can see this picture, the ball kept on the rooftop, the ball has potential energy. You can see this third picture, stored water in an overhead tank. The tank contains water. The tank is in the top of the place. So this over tank has potential energy. So these are all the examples. Keep it in your mind. So next we are going to see about some numerical problems, so related to potential energy. So, students, the first question is, what is the energy stored in a stone of mass 450 gram, which is kept at the top of a building of height 30 meter? So, here they are given three values. One is the mass, another one is the height, and third one is the gravitational force. So, gravitational force is 10 meters second power minus 2. So, what do we have to find out? What is the energy stored in a stone? So, first we have to write the solution. They are given here mass is 450 gram. So here they are given in gram, mass is they are given here gram. So we have to convert it into kilogram. So 1 kilogram equal to 1000 gram. So I am going to reform this gram to kilogram, 0.45 kilogram. So next the gravity 10 meter second power minus 2, height is 30 meter. And next we have to write the formula. Already we know that about the formula for potential energy. Potential energy is equal to mass into gravity into height. So I am going to apply these values into that formula, 0.45 into 10 into 30. So after multiplication we can get 135 joules. So students, the energy stored in the stone is 135 joule. This energy stored is gravitational potential energy. So, second question, what is the weight of the object that has gravitational potential energy of 4800 joule if it is dropped from the height of 6 meter? So, in this question, what are the value they are given here? Energy, they are given energy 4800 joule and height 6 meter. So, what you have to find out? Weight of the object we have to find out. So, solution I am going to write potential energy is equal to 4800 joule and next height is 6 meter. So already we know the student the formula for potential energy, weight into height. So think of that. So before that we write like this, m into g into height, but here we written like this, weight into height. So where is the m and where is the g? So students, the weight how we measured is mass into gravitational force. So when we multiply mass into gravitational force, we can get weight. So in this question, they are given weight. So only I written like this the formula, potential energy is equal to weight into height. So I'm going to rearrange this formula because they asked weight only. So I'm going to rearrange this formula. Weight is equal to potential energy divided by height. I'm going to apply these values into the formula, 4800 divided by 6. So finally we can get 800 Newton. So the weight of the object is 800 Newton. So students, third question, we are going to discuss about third question. Here they are given a 34 Newton object is lifted to a height of 12 meters. What is the gravitational potential energy of this object? So here I am going to write what they are given in the question. I am going to write. So weight they are given here 34 Newton. Then height they are given here 12 meters. So what you have to find out, what is the gravitational potential energy? So already we know that the formula for gravitational potential energy, what is the formula? Potential energy is equal to weight into height. So I'm going to apply these values into that formula, 34 into 12. So finally we can get 408 joules. So what is the potential energy of this object? The potential gravitational potential energy of the object is 408 joules. So students, next we are going to discuss about elastic potential energy. So what is elastic potential energy? The energy of a body due to a change in its shape and size is called elastic potential energy. So students, you can see that the picture, this is archer. Okay, this is an archer. அதை வில் அம்பு அப்படின்னு சொல்லுவோம். ஸோ இந்த வில் அம்பை நம்ம எப்படி நம்ம யூஸ் பண்ணுவோம் அப்படின்னா, ஃபிக்ஸ் பண்ணிவிட்டு அந்த அம்பை ஃபிக்ஸ் பண்ணிவிட்டு அந்த அம்பை என்ன பண்ணுறோம், ஸ்ட்ரெச் பண்ணுறோம். ஸ்ட்ரெச் பண்ணிவிட்டு அதை ரிலீஸ் பண்ணும்போது அந்த அம்பு அந்த ஆர்ச்சர்லேருந்து ரிலீஸ் ஆகி ட்ராவல் ஆக ஆரம்பிக்குது. ஸோ இன்னும் சிம்பிளாக சொல்லணும் அப்படின்னா ரப்பர் பேண்ட். ஓகே, ரப்பர் பேண்ட் நம்ம எடுத்துக்கலாம். ஸோ ரப்பர் பேண்டு என்ன பண்ணுறோம், ரப்பர் பேண்டை எடுத்துகிட்டு அதை வந்து ஸ்ட்ரெச் பண்ணும்போது என்ன ஆகுது, அது ஸ்ட்ரெச் ஆகுது. அந்த ஸ்ட்ரெச்சை ரிலீஸ் பண்ணும்போது it given some kind of force. You can see this catapult. So catapult also like that. So next you can see that the spring. So the sofas நம்ம வீட்டில் எல்லா வீட்லேயும் சோஃபா இருக்கும். சோஃபாவில் நம்ம உட்காரும்போது என்ன ஆகுது, அந்த ஸ்ப்ரிங் கம்ப்ரஸ்ட் ஆகுது. ஓகே, when the spring is compressed it has potential energy. ஸோ நம்ம எந்திரிக்கும் போது என்ன ஆகுது, அந்த கம்ப்ரஸ்ட் ஸ்ப்ரிங் வந்து extended ஆகுது. ஓகே, so extended spring also has potential energy. These are all the example for the elastic potential energy. So next, so students, elastic potential energy is associated with the state of compression or extension of an object. So these are all the very important point. The elastic potential energy is associated with the state of compression or extension of an object. So for example student, the energy possessed by a compressed spring or an extended spring, stretched spring is the elastic potential energy. So already I told you. So if it is a spring is in the position of compressed or is in the position of extended spring, the spring has elastic potential energy. The gravitational potential energies as well as elastic potential energy are commonly known as just potential energy. So students, clearly we have to know whether it is a gravitational potential energy or whether it is a elastic potential energy. So both commonly we can call it as potential energy. So thank you children for your listening. Thank you so much.